and reference it if you need. Okay, so let's start with those co-function properties. I'm going to go through kind of how we get them, and then we'll talk about the longer, slightly more complicated ones in a minute. All right, so on the screen, you guys, I have a triangle situated in the first quadrant, and I've defined this angle here, the origin, as theta. And knowing what we know about sine, cosine, tangent, secant, cosecant, and cotangent, we can define the sine of theta as side b over r, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and so forth. So I've got all the definitions for sine, cosine, tangent in terms of a, b, and r, our side lengths of this triangle. Okay, what happens though if I rotate this triangle? Same exact triangle, just rotated, oriented slightly differently in the first quadrant, so that theta is now this angle over here. And the angle sitting at the origin is no longer theta. Well, when I do that, okay, when I rotate this triangle, I switch these sides. So A now is this side length and B is this side length. They're the same as they were over here. The orientation of the triangle is the only thing that's changed. And I also know something about the angle that is now sitting at the origin. This angle, because this is a right triangle, must be 90 minus theta. It must be 90 degrees minus theta. So now, using A, B, and R, I can define the sine of 90 minus theta. The sine of 90 minus theta, that's just the side opposite this angle, which is A, over our hypotenuse, which is R. So the sine of 90 minus theta is A over R, but we also defined A over R to be the cosine of theta. So this is where we get the first co-function property. The sine of 90 minus theta is equal to the cosine of theta. We can keep going. The cosine of 90 minus theta, that's just b over r, but we defined b over r to be the sine of theta. So the sine of theta is equal to the cosine of 90 minus theta. Right? The other angle in our triangle. Right? The cosine of one angle in our triangle is equal to the sine of the other non-90 degree angle in our triangle.
So I'm kind of confused. What do you write in the co-function properties?
Sorry, David, can you say that one more time?
So what do we write in the co-function properties? Like, do we write that sine is equal to cosine 90 minus?
Yeah, I'm going to give you guys a page in just a minute with everything on it. So hold tight on that, and then I'll show you where to write in what you're going to write in a minute. I'm just showing you how we're going to derive this for now. Yeah, good question though, sorry. Okay, so tangent of 90 minus theta, well, tangent is just A over B. It's opposite over adjacent, but we call the tangent, we called A over B the cotan of theta. And then the secant of 90 minus theta, well, secant is just the reciprocal of cosine. So we have r over b in this case. We called r over b, though, the cosecant of regular theta. Okay, cosecant of 90 minus theta is the reciprocal of sine, so that's r over a, but we defined r over a also as just the secant of theta. So last and best guess as to what the cotangent of 90 minus theta is going to be. Right, that's just the tangent of theta. Okay, so here's what we're writing on our trig properties handout. On your handout, can you guys just nod if it says radians? Does it say radians on the handout next to the cofunction? Great. Okay. So here's what you guys are going to write. You guys are going to pay attention to the right column here. These are the ones in radian. On the right, the left-hand side, I just have it all in degrees instead. But this is the one you guys are going to copy. And here's what you're going to write. So the first line is the sine of x. So the sine of x, you're just going to rewrite the cosine of pi over 2 minus x. So that's how you're filling in that properties handout. The sine of x is equal to the cosine of quantity pi over 2 minus x. And then moving to the right, the secant of x. Secant of x is equal to the cosecant of pi over 2 minus x. So take a minute, write this down. I don't want to leave anybody behind. So once you're done copying, if you could just raise your hand on Zoom so I can take a look to make sure that we're all ready to move on, that would be lovely. Thank you, Asher and Ron, for raising your hand. When you guys are done, raise your hand so I know we're ready to go. I'm not going to call on anybody. I just want to know you guys are ready to move on. All right, I'd say of all of the trig identities, the co-function ones, like not terribly overused. Like you're going to use Pythagorean theorem probably more often than anything else. Pythagorean properties in your proofs. Co-function, you'll see a couple of now that we've talked about it, but they're just nice to have on the paper. Good to know. All right, take a little bit longer, and then we're going to move on to the next set of properties. I'm going to sing for you guys in a minute. Not sing, more like chant. All right, at any time, you guys, if you've got a question, just throw it in the chat. I've got the chat open here. We're going to move on to the composite properties. So these are the ones at the top of your page. We will cover the last set, the double and the half argument properties next week. The composite arguments, we're going to just start by writing them in. All right, so take a minute, just write them down, and then we're going to talk about them. When you're done writing these ones in, please raise your hand on Zoom so I know we're ready to go. You're going to start with the tangent. So tangent ones start on your paper at the top. So the tangent of a minus b is this expansion, the tangent of a plus b, and so forth. All right, so take a few minutes, raise your hand when you're done. And then I'm going to go through a way to help remember these. All right, once you've got these written down, find your note packet, open up to page 10. We're going to use them. All right, guys, hands up if you're ready to move on. Thank you, everybody, for raising your hand. Connor, don't worry. If you need me to go back to these at the end of the lecture, I will. All right, so if your printer's not working today, you can jot them down somewhere else, or I can go back to these later. Awesome. Okay. Think about a song, or mostly song. Think about like the song that if you hear gets stuck in your mind and you can't get it out. For me, it's a small world, right? If I hear it's a small world, it's not leaving my head. Okay, my goal today is to annoy you into learning these properties with a chant that I'm about to do, okay? So if you learned the quadratic formula by song, right? X equals opposite B plus or minus the square root, that one also kind of gets stuck in your head. We've got chance to learn the sum and difference formulas as well. Now, obviously on the test for this year, at least in distance learning, you can reference your handout. But it's always really nice to know that these properties exist. Like I said, every year I give the properties, the full list of properties for the proofs test, and people still fail that proofs test, even having the properties with them, because they just don't know them. So knowing the properties is really, really important. Not necessarily having them like fully memorized this year, of course, but if you don't know that they're there, you don't know to use them. So we're gonna learn these ones. And I'm gonna chant them for you. So let me find like a pointer here so that we can go through them. I'm gonna start at the top. So for you guys, it doesn't follow the order of your page, but let's just take a look. So if I can express the cosine of some angle A minus some angle B, or some angle A plus some angle B, right? We expand it as the cosine of A times the cosine of B plus a sine A times a sine B. Now here's how I remember cosine. Cosine starts with C, so does the word change. So for cosine's expansion, we change the sign. So if the sign here is minus, the sign here will be plus. Okay, cosine starts with a C, so does the word change. We change the sign. If the sign here is plus, the sign here for the expansion will be minus. Sine's expansion looks a little bit different. So to expand the sign of A plus B or A minus B, it's going to be sine A times cosine B minus cosine A times sine B, or plus cosine A times sine B. This expansion, you guys, especially for the subtraction, order is really important. So we want to make sure we are expanding correctly. But for sine, sine starts with an S, so does the word same. So the sign stays the same when we're expanding for sine. If it's minus here, it's minus here, plus here, plus here. Tangent will be the same as sine. So with tangent, the expansion for A minus B or A plus B is tan A minus tan B over 1 plus tan A times tan B. The sign will be the same on the top for tangent, and then the sign changes in the bottom. So if it's plus here, it's plus on the top and minus on the bottom. All right, so the chant is not going to help you remember the signs. You have to remember that otherwise, but it will help us remember the order. Okay, so here we go. I'm going to go with this pointer. It's going to be like a sing-along on the Disney Channel. Okay. Cosine, cosine, sine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, sine, cosine, cosine, sine, tan, tan, 1 tan, 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 1 tan, tan. All right, that's the chant for these properties. And I'm going to do this as we go through, and I think it'll just be really easy for you guys to start memorizing these. A little bit easier than the Pythagorean ones, which don't have a chant to go with it. All right, if you are a person that's super interested in the proofs of all of these, I have slides at the end of the slideshow that walk us through the proofs. If you want to know them, stick around. We can go through them at the end of the period, but I'm not going to cover them in lecture today just because it'd make the lecture really long. All right, so we proved the cofunction. We're not going to prove these ones. We're just going to use them. So turn to page 10 on your student note packet. Page 10 looks like this. We've got a couple of examples we're going to work through. You guys are going to do the homework the exact same way we're doing these problems in the lecture. So that means no calculator, and you're going to show all the steps. So I'm looking for all the steps fully worked out. If you don't show work, you're not going to get credit for this homework assignment. The one nice thing though is you can always check your work with a calculator. So you can always go back at the end. You can plug this into a calculator and see if your answer is correct. But I'm going to ask for exact values only on the homework and on the test, which means no decimals. We're going to just simplify the square roots. All right, so here's the deal. Cosine of 75 degrees. If we don't have a calculator here, 75 degrees is not an angle on our unit circle. It's not a nice angle. Unit circle angles are like 0, 30, 45, 60, 90. Those are nice angles on our unit circle. 75, not the case. So if I can find a way to express 75 as the sum or difference of two angles on our unit circle, then I can approach this problem using the sum and difference identities without a calculator, right? That's our goal here. So degrees, a lot easier to approach than radians. We'll do a practice in both. But let's talk about the cosine of 75 degrees. Look at your unit circle. See if we can take two angles on the unit circle, add them together to get 75 degrees, or subtract them to get 75 degrees. And I will say most often people are going to pick 45 degrees plus 30 degrees to get 75. It's not the only option. It's probably the option that makes this problem a little easier. Okay, so now what I do? Well, I just took this cosine of 75 and I separated it. I turned this into the cosine of 45 degrees plus 30 degrees. I turned this into a problem that is the cosine of angle A plus B. And I know the expansion for that, right? We just learned it. Cosine, cosine, sine, sine, cosine, cosine, sine, sine. So this is going to be the cosine of A times the cosine of B. Cosine starts with a C, so does the word change. So we need to change the sign. It's A plus B, so we're going to expand it as minus sine A sine B. Okay, I'm going to put a star next to this step. This step is optional on your homework assignment. If you don't want to write that step, that's fine. But this next step you do need to show. We're going to show the substitution of angle A and B. So angle A, I said, was 45 degrees. So this becomes the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. Okay, I do need to see the step in green on your homework assignment. Writing the step in red is highly, I recommend it, highly recommended, just because it gets you to know the properties faster if you guys are writing them out on your homework. Okay, but the very minimum, write the line in green there. Okay, and then we can use the unit circle to actually evaluate. The cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2. And then sine of 45, root 2 over 2, sine of 30 is 1/2. And then we're going to simplify. So I'm trying to color code each line just in case we need to go back. The square root of 2 over 2 times the square root of 3 over 2, that's just root 6 over 4 total. Exact answers only means no decimals. So the only thing that I can do is I can just write everything over a common denominator. This just becomes the square root of 6 minus the square root of 2 over 4. Can't go any further than that. All right, we're going to come back to B. I'm going to put a star next to that. We're going to leave that. If we've got time, we'll come back. If you've got questions, throw them in the chat as we go. So take a look at C. C is a little bit different. 2 reasons why. We're dealing with sine, and we're also in radians this time. Okay. Radians make it a little more challenging. It's up to you guys how you want to approach this. I think a lot of times it's easier for people to turn the radians into degrees first and then try and figure out the sum or difference of the angle in degrees. If you can go straight to adding 2 angles in radians to get 7 pi over 12, that's also fine. I'm going to do it this way. 7 pi over 12 in radians is what in degrees? Well, I can just multiply that by 180 over pi to turn it into degrees. The pi's cancel. 180 divided by 12 is 15. So this is 7 times 15 degrees, which is 105 degrees. All right, 105 degrees though, that's not a unit circle angle. So I can try and find two angles on the unit circle that add or subtract to 105. I think oftentimes people will pick 60 plus 45. And now we've got another case where we're going to need to use the sum and difference properties here. We've got the sine of angle A plus B here. So I know a way to expand that. For sine, it's going to be sine, cosine, cosine, sine. Sine, cosine, cosine, sine. So sine A, cosine B. Sine starts with an S, so does the word same. The sign is going to stay the same. All right, and just be careful about the order that you're doing this in, right? You want to take the sine of angle A and B in this whole expansion and the cosine of angle A and B. A lot of people mix the order up and then end up taking like the sine of A and the sine of A again, right? Just be careful there. Again, I'm going to put a star next to that. You can write that on your homework. You don't have to, but the next step you do need to show. So the substitution here, A is 60 degrees, the way that we've defined this. B is 45 degrees. So when I substitute the angles, we've got the sine of 60 times the cosine of 45 plus the cosine of 60 times the sine of 45. Because these are unit circle angles, we can just evaluate. So the sine of 60 degrees is root 3 over 2. The cosine of 45 is root 2 over 2. The cosine of 60 is 1/2, and the sine of 45 is root 2 over 2. Simplify. Again, exact values only, which means we're going to leave everything in simplified radical form. Root 6 plus root 2 over 4, that's as far as we can go there. Okay, for the last problem, I'm going to work this through with you guys. I would write small. Okay, just my warning. The box is small for the algebra we're going to do. Purple step required, yes. I want to see the green step and the purple step. The substitution of the angles and then the substitution from the unit circle. All right. Tangent of 15 degrees on our unit circle. Two angles that add or subtract to 15. 60 and 45. You could use 45 and 30. Okay, so the expansion of the tangent of A minus B. We've got A minus B here. That is going to be tan, 1 tan, tan, 1 tan. So tan A minus tan B, the sign stays the same on the top, and then it changes on the bottom, 1 tan. So 1 plus the tangent of A times the tangent of B in the denominator. Blue step you don't need to write, the green step you do. So let's substitute. This is going to be the tangent of 60 minus the tangent of 45 over 1 plus the tangent of 60 times the tangent of 45. Okay, purple step we also need to show. So the tangent of 60 degrees, I'm going to do this over to the side just because I'm going to run out of room if I don't. Okay, so on your unit circle, the tangent of 60 degrees, go to 60 degrees. Tangent is always sine over cosine. So the sine here is √3/2. Cosine is 1/2. So the tangent of 60 degrees is equal to the square root of 3. If I just show that work on the side, it's going to be a little bit easier as we work through the simplifying. The other angle that we're taking the tangent of is 45 degrees. The tangent of 45 degrees, that's a lot easier to work with. It's just 1. So let's plug those values that we just found into this equation in green here, or this expression, I guess. The tangent of 60 is the square root of 3. The tangent of 45 is 1. This is all over 1 plus the tangent of 60, which is √3, times the tangent of 45, which is 1. Okay, so we're at this step here. You cannot box that as your final answer, you guys. If you were to leave that as your final answer on a test, that would not be full points because there is a radical in the denominator. We got to rationalize this. So I know how much you probably loved this unit in Algebra 2, but think back to that and how we got rid of radicals in the denominator when they looked like this. And this is actually going to be a common step that we take in proofs as well. There's a fancy word, kind of a weird one. We're going to multiply by the conjugate of the denominator in order to get rid of the radical. So this is where I said leave some room here. I'm going to move all of this up here. And the conjugate of the denominator, we just take the denominator and change the sign in between the two terms. So that is going to be 1 minus the square root of 3 over 1 minus the square root of 3. It's a fancy form of 1 coming from, again, the conjugate of the denominator. There were a couple of proofs in the homework this week where that was a step that was helpful. If you multiplied the top and the bottom by the conjugate of the denominator with the trig stuff, it could clear denominators a little bit easier. Okay, and then we just FOIL, right? So this is the square root of 3 minus 3 minus 1 plus the square root of 3. All over 1 minus 3. Combining like terms in the numerator, we get 2 root 3 minus 4 all over 2. And then we can pull, that's a negative 2. We can pull a 2 out of both the terms in the numerator. Right, so I can simplify. This is going to be 2 minus root 3. I would say that applying the trig property there is not what makes that problem difficult. If you do not show the multiplying of the conjugate, you will lose points on the test because I don't know if you're using a calculator or not at that point. Okay, so show your work. You can always check it with a calculator, especially if you have one of these ones. These little scientific calculators, these ones are great. They do square roots very nicely. You can always check your work there, but if you're not showing all the steps, you're not going to get full credit. Okay, other questions? Throw them in the chat if you've got them. Unmute yourself if you need to. We're going to move on. Bottom ones at the very bottom of page 10. We're going backwards. So these ones are a little easier, I think. If we can identify a pattern, then we can solve these problems without having to use a calculator. So 80 and 20 degrees, not an angle or angles on our unit circle. So if we can approach this a different way, we can evaluate this without a calculator. So if we look at this, this is sine, cosine, cosine, sine. Sine, cosine, cosine, sine. That is the expansion for sine of a plus b or sine of a minus b. Because the sign here is minus, this is going to be the expansion of the sine of a minus b, some angle a minus b. Right? In this case, a is 80 degrees and b is 20. This is the sine of 60 degrees, which is the square root of 3 over 2. Okay. This is all you need to worry about showing on your homework. F is a little more obvious, maybe. Tan, 1, tan, 1, tan. This is going to be the expansion of the tangent of some angle A plus B. I know it's plus because there's a positive sign in the numerator. Okay, A in this case, 22 pi over 15, and B is pi over 5. Leave some room here. I just need to find a common denominator to see if I can get this simplified to an angle on the unit circle. It should always simplify to an angle on the unit circle, you guys. If it doesn't, and I give you this problem on like a test, you did the addition wrong. So always check, right? It should always work out eventually if you're doing it correctly. Common denominator is going to be 15 here. So I'm going to multiply pi over 5 by 3 over 3 in order to get 15 as my common denominator. This is going to become the tangent of 25 pi's over 15, which simplifies to the tangent of 5 pi over 3. Right, so 5 pi over 3, it does work out. That is a unit circle angle down there in the 4th quadrant. Tangent is always sine over cosine, so the sine of 5 pi over 3 is negative root 3 over 2, and the cosine is 1/2. Final answer is negative root 3. All right, last set of homework problems for the homework due on Tuesday is going to look like problems on page 11 of your student note packet. So the last set of problems relates to 31 through 36 on your homework. You're going to draw the diagrams. I'm going to be checking for diagrams first. You get points on your test for drawing diagrams also. And then we're going to get the information from those diagrams to use for the remainder of the problems on page 11. So let's take a look. On page 11 of your student note packet, we've got alpha and beta defined as the following. The sine of alpha is equal to 4 over 5, and we're told that alpha lies between pi over 2 and pi. And then beta here, the cosine of beta, we're told is negative root 5 over 5, and beta lies between pi and 3 pi over 2. So let's draw the diagrams and label them before we do anything else. Now, alpha first. Alpha is between pi over 2 and pi. Pi over 2 and pi puts us in the second quadrant. So all I need to do is sketch the second quadrant. I don't need to see anything else. I'm going to drop this angle in the second quadrant and draw a triangle. Okay, the perpendicular always hits the x-axis. One thing I am going to note that technically that's the angle alpha there. Always measured from the positive x-axis. And we're told that the sine of this angle is 4 over 5. So what would make that true? Well, that would require the height of this triangle to be 4, the hypotenuse to be 5 here. One more thing we're going to fill out for the diagram is that x component. So if you remember back to geometry, those Pythagorean triples makes your life a little bit easier. 3, 4, 5 is a Pythagorean triple. It's -3 because we're sitting in the second quadrant. X values in the second quadrant are going to be negative. And then I'm just going to make a note. I can figure out what the sine, cosine, and tangent of alpha are. The sine of alpha is 4/5. The cosine of alpha is -3/5. And the tangent of alpha, well, that's just opposite over adjacent, is -4/3. I'm just making a note of that. We'll use those in just a minute. I'm going to move over to beta, draw the picture for beta, the diagram. Beta, we're told, is between pi and 3π/2. That is down in the third quadrant. So let's sketch the third quadrant. Don't need any other quadrant in your diagrams. Angle is going to go to the third quadrant. It's a sketch, right? It doesn't matter where the angle is, you guys. I'm going to drop my perpendicular always to the x-axis. I'm going to mark that this angle right here is what beta is, right? Measured from the positive x-axis going counterclockwise. What makes the cosine of this angle -√5/5? Well, to get the cosine to be -√5/5, that requires the x component here to be negative. Hypotenuse is always positive. So the x component is -√5. Our hypotenuse is 5, so we need to figure out the height of this triangle, right? Or the y component. We're going to do that using Pythagorean theorem. I will not mark off points if you don't mark the angle. I'm just marking the angle so that you guys kind of can contextualize, right? I'm looking more for the values. All right, Pythagorean theorems tells us that the y component is equal to the square root of 5 squared minus -√5 squared. Which simplifies to the square root of 20, which we simplify even further. That is going to be 2√5. And it's negative because in the third quadrant, y values are negative. Pythagorean theorem you can do in your head, that's fine. All right, so I can find the sine here, -2√5/5. The cosine, we were told, was already -√5/5. And then the tangent is -2√5/5. It's just +2. Okay. Once we've got our diagrams and we've got all the information about each angle, we can start applying the properties we just talked about in order to evaluate A, B, C, and D. So let's do that. We're going to skip one of these examples for time. All right, let's take a look at example A here. I've got the sine, cosine, tangent of both angles on the upper right-hand side here. So we can go back and reference those. The sine of alpha plus beta. So we want to use the expansion here for sine, sine, cosine, cosine, sine, sine, cosine, cosine, sine. Sine stays the same. Right, step in blue, you don't need to worry about writing, but I do want to see the step in green, which is the substitution. So the sine of alpha we said was 4/5. The cosine of beta here was -√5/5. And then from our diagram, we found that the cosine of alpha was -3/5, and the sine of beta was -2√5/5. And then we just simplify, right? This is negative 4 root 5 over 25 plus 6 root 5 over 25. Final simplified answer, exact values, 2 root 5 over 25, right? No decimals. Keep the square root simplified. Okay, I'm going to pause my screen. You guys try B. Do it on your own before I do the answer. I put the answer up. Use the expansion. Substitute. Okay. Expansion for the cosine of a plus b is cosine, cosine, sine, sine. Cosine starts with a C, so does the word change, so we have to change the sign. Final answer here, when you simplify everything, it should be 11 root 5 over 25. All right, guys, any questions before we move on to the last example for today? Great. Okay, we're going to skip C and we're going to do D last. I want to be able to get to questions on the proofs if you guys have any. So skip C, let's do D, which is the tangent expansion, and then we'll go through proofs if you guys have questions. So tangent of alpha minus beta, well, that's going to expand tan, 1 tan. So tan alpha minus tan beta over 1 plus tan alpha times tan beta. And we just need to substitute. The tangent of alpha we said was negative 4 over 3. We're subtracting the tangent of beta, which we said was 2. And then this is all over 1 plus negative 4 over 3 times 2. Just got to find a common denominator in the numerator and the denominator. 3 is going to be our common denominator, so that's going to give us negative 10 over 3 on the top. And then in the bottom, we're going to have 1 minus 8 over 3. 3 is going to be a common denominator in the bottom as well, which will give us negative 5/3. And then conveniently, and I want you guys to see this step because this is really useful in proofs as well. Anytime the numerator and the denominator have the same denominator, they cancel like that. Positive 2 becomes our answer. Negative 10 over negative 5. This is being recorded. I'll post this afternoon. Okay, so follow the steps that we took in lecture today when you guys do the bookwork. The bookwork is due next Tuesday, not next Monday, because you guys don't have school on Monday. So I see you guys on Tuesday. Hopefully you know that. Tuesday, we'll come back. We will start in on 7/7. Office hours today, normal time, 2:35 to 3:15 if you want to drop by. If you want to make an appointment with me on Canvas to meet individually tomorrow, do so. I did see that I had some people reserve spots already, so get that reserved as soon as possible if you want to meet tomorrow. And then this is what you guys are turning in Tuesday by 8:45. All right, so don't forget to do the notes handout as well in your scans. Otherwise, you do lose points for that. And if you have questions, I'm going to have you guys stick around. So if you have questions, especially on like 59 and 60, maybe 61, 62, those were some tricky proofs there. I would say this, if you think, like based on what you guys did with your homework, if you could do the proofs from the left side or from the right side, and both, then you guys are good to go for the test. So if you could do any of the homework problems that I gave you guys between Tuesday and Thursday, if you could do them, having me define the side that you guys needed to start on, then you should be good to go for the test. All right. But if you had questions, stick around. I'm going to go through some of these with you guys.
Miss Wong,
Have a great weekend. Thank you.
All right. See you.
Miss Wong,
Thank you.
you're gonna have us start at 1 and go to something really complicated.
No, I will never have you start at 1 and go to something really complicated. Yeah, no, that's a really good question. There's actually one proof somewhere along the way where you have to go from 1 at some point in the proof back to like reciprocal property, like sine times cosine.
Well, it would be fine because you just make it into one of the Pythagorean stuff,
Yeah.
and then you go from there. It still seems scary.
Exactly, but I won't on a test. No, I will not have you start at 1. That'd be pretty mean.
Okay.
Yeah.
Okay. Have a good week.
Bye.
Bye.
Yeah. All right.
Miss Frank,
Yeah.
I can't find the office hours sign up. Is it on Canvas? Is it like?
Yeah. So if you go to your calendar on Canvas, are you there?
Uh-huh.
And if you go to find appointment,
Yeah, it's loading.
okay. If there's no appointments that shows up, it means that they're full. So they were almost full this morning when I checked. I haven't checked since this morning, so it might be full. I'll look. There should be, if there's an appointment slot available.
Oh, yeah, I didn't see that.
Got it. All right. So make that appointment if you can see it.
Okay.
All
Thank you.
right. Welcome. See you guys. If you don't have any questions, you're welcome to log off and get started on the homework. I wanted to talk about some proofs, unless somebody has a specific question about the lecture first.
Yeah, I have a specific question.
Go for it.
My Wi-Fi was cutting out for like 60 or 70% of that lecture.
Okay.
Is it being recorded?
Yes, I'm going to post it as soon as I'm done with class.
Awesome.
Cool.
Okay, that's it. Thank
All
you.
right.